Day grade 11 chemistry students, what we're learning about today is quantities and chemical reactions. Specifically, we're learning about the law of definite proportions. Okay, we're going to learn something about percentage composition in terms of mass data and molar mass. So we will explain this as we go. The next couple lessons after this, we're going to do empirical formula and molecular formula, but today we're focusing on the law of definite proportions. Okay, so what is the law of definite proportions? Well, the law is the proportions of an element in a compound will always remain the same. This means any compound, for example, like water, if we talk about its mass, a certain percentage of its mass, a constant percentage, I'm just going to make up a value. I don't know, this is not correct, but let's say 70% of its mass comes from oxygen, okay, and the remaining mass comes from hydrogen. Now, when I think about that, those numbers are completely wrong for water, but whatever the percentage is, those values are constant. It doesn't matter how much water you have. 70% of the mass of water will always come from oxygen. So if you have 100 kilograms of water, 70% of that mass comes from the oxygen, and 30% of that mass comes from hydrogen. It doesn't really matter what sample you have. Now, we're going to talk about how we find this percentage composition, okay? Definite proportions kind of lends itself to something called percentage composition. So we actually can find percentage composition from data, or we can actually find it from the actual chemical formula. So if we know the chemical formula, we can find it easily. I'll show you an example of that. And if we have the data, we can find it as well. So here's an example where we actually have some data. It says we have a sample. So we don't know what the chemical is, but we know that we have a sample that weighs 48.72 grams. And in that sample itself, we have combustion analyzers and ways to analyze it and determine what percent or what mass of the elements that exists within that sample. So we have 48.72 grams of a sample, 32.69 grams come from zinc, and 16.03 grams come from sulfur. So if you add these two numbers together, we should get 48.72 grams. Well, how do we find the percentage composition of the compound? This should be pretty easy to you because if we know the total mass and we know our individual mass, we can do just some simple mathematics. And all we have to do to find a percentage is we take the mass of our compound, which in this case is zinc, and we divide it by the total mass of our compound and we multiply by 100%. And we find out we get 67% zinc, okay? And we do the same thing for sulfur, divided by the total mass of the compound, multiplied by 100, we get another percentage. When we add these together, we should get 100%. Now, for this compound, whatever the formula could be, it could be ZnS2, it's probably going to be ZnS, okay, because we know about our charges. But the point is that generally these percentage will stay constant for all these compounds. Okay, so just to recap, if we have data, we just take the sample of the total sample mass and we divide it into the individual mass from the individual element, multiply by 100, you get a percentage. Well, what if we don't have any lab data? Instead, we just have the molar mass. How can we turn that into a percentage composition? Now remember, percentage composition is percent mass. Okay, so how can we take this example here, like we have a compound that's responsible for the odor of cinnamon? How can we find the mass percentages of carbon, hydrogen, and oxygen? Well, what we can do is we can just use the molar masses. So for example, this is saying if we want to find the percentage for carbon, we take the molar mass of 9 carbons, because 9 carbon make up this, and we divide it by the molar mass of our substance. So we're going to, instead, because we don't have data, we generate data from the molar mass. So what we do is we take 9 times 12, and that will give us a molar mass of 108.09 grams per mole. And we divide it by the molar mass of the whole substance. So 9 carbons plus 8 hydrogens plus an oxygen, and we multiply by 100. So we find out that 81.78% of our mass comes from carbon. We then just do the same thing for hydrogen, 1.01 grams per mole times 8, and that will give us 8.80 grams. That's the mass from hydrogen. Divide by the molar mass of our whole substance times 100, and we get a percentage of 6.11%. So 6.11% of the mass of any sample of this compound, of this cinnamon compound, will be from hydrogen. Okay, And finally, we do the same thing for oxygen. Just one oxygen, so just 16 times 1, 16 grams per mole, divided by the whole molar mass, times 100, 12.11%. Now, if we add all these guys together, we should get a molar mass of 100%. Okay, so the last thing we're going to do here really quickly is we're going to show one more example, find the percentage composition. Now remember that if we don't have data, we got to use our molar masses. So if we look at this example, we want to find the percentage composition of iron and the percentage composition of oxygen. And to do that, we don't have data, so therefore we have to use our molar masses. So what I've written here is I've got the molar mass of 2 irons plus 3 oxygens. There's 2 irons there, 3 oxygens. I'm just going to add that all up. So we substitute in our molar masses. We get 111.7 grams per mole here. And we have 48 grams per mole here. Now, what we're going to do is we're just going to add that together, get our whole molar mass, which just is 159.7 grams per mole. To find the percentage of iron, we have 2 irons, so we're going to take the molar mass of 2 irons, which is just this right here. So molar mass of 2 irons divided by the molar mass of Fe2O3. Put those numbers in there and you get a percentage. So my percentage ends up being 69.94% from iron. So obviously the rest of that's coming from oxygen, but let's, instead of just doing subtracting from 100, let's actually go through the calculation and I'll show you that now. If you plug your numbers in, 16 times 3 is 48, divided by the whole molar mass, 159.7, and multiply by 100, and you get 30.06%. And that's it. That's how you find percentage composition, okay? So we learned the law of definite proportions, which says that, for example, rust, Fe2O3, will always exist in 69.94% iron and 30.06% oxygen by mass. It doesn't matter what size of sample you have. Those are the proportions that will always exist for Fe2O3. We learned that we can find percent composition by either from data, like we learned in this example. So in this example here, we had data. And in this example here, we had no data, so we used the molar masses. So there's 2 ways. That's it. No actual question for you tonight. Just go on to the next video, and hope you had a nice weekend.